All right. Where were we yesterday? I probably should have done that before. I had it before. Went off on that thing. All right. So now we're going to talk about construction of batteries. And we're going to change the color back to black. So construction. All right. So we watched the little movie. Yes, we did. Okay. One battery consists of a group of cells connected, and you tell me, are they connected in series or parallel? Series. Why do we connect them in series?
Increase voltage.
Okay, increase the voltage. So if we talk specifically about like a 12-volt battery, let me see, I'll write this so you make sure you get it, in series. In series. And of course, encased together, you can't tell that they're in series by just looking at the casing. Wow.
Is that always the case? I mean,
No, it's actually not.
okay.
Especially if you look at some, I've seen some NiCad batteries, when they put the cells in, they'll actually...
Series and parallel?
Depends on the battery, but if we're talking about lead acid battery, like the standard type, no, you could still put them in series and parallel.
Because I've seen like tractor batteries that have
Oh yeah.
both,
Uh-huh.
and they're really big.
Oh yeah, they're huge. So it depends on the size of the battery. All right, so let's just take that and run with it just a little bit. Let's say I had a 12-volt battery, but I needed to run a lot of amps. What could I do?
Parallel with the battery.
Well, inside the battery, how would they hook the cells up? They go series parallel. So in other words, I can take one cell and hook it parallel to another one, and then run those to another in series with those two, and then series with these two, and so it's just parallel series. So, oops. Okay. Oh yeah, there's a Q&A question. It's got batteries in series and parallel. Remind me to show you how to do that one real easy. Otherwise it's hard. So each cell has a positive and negative. Positive and negative. Positive and negative plates. Alternating with insulating material between. Called separators. Now these separators actually have a pretty important function. There are some times when a battery will, that's one of the tough parts about electricity that you will be dealing a lot with in aviation, especially in general aviation, is people will come in with a problem with the electrical charging system. Aircraft won't start. Why won't it start? Is it a dead battery? Is the battery good but the charging system is bad, or is it some other problem? So you're going to have to diagnose these things, and it's helpful to know how batteries are built so that you can kind of, in your mind's eye at least, say, okay, I understand what's going on inside the battery and why maybe your battery is giving this problem. So in other words, if we have a 12-volt battery, which this is, 12-volt batteries will always have 6 caps. Providing you can see the caps. Sometimes you can't see them, but there's still 6, so it tells you a 12-volt battery has 6 cells, so it's roughly how many volts per cell?
2.
Roughly 2. Okay. And so let's just say suddenly you got a battery that just is 10 volts.
One cell's bad.
One cell went bad. How can a cell go bad? Well, there's a lot of ways, but the 2 most common ways are abuse. I probably shouldn't be touching this, it's lead. If you overcharge it, these plates can warp. They can break through the insulating material and touch each other. You short it out. Also, these plates give off, I'm just going to say garbage right for the moment, and they give off the particles, debris that falls down in, and it fills up the bottom of the battery, and it will short them out. So you can short out batteries.
Is that just a byproduct of the chemical reaction?
Yeah, it is. It's sulfation. I'll cover that. But that's lead. You're not supposed to touch lead. All right.
Hand sanitizer?
All right. So you got these separators. And what are these plates made out of? So plates.
Plates.
And we're talking strictly lead acid battery here. Plates. They're made out of a lead compound. The positive plate is lead peroxide. Which is PB02 if you're cared. And the negative plate
PB0.
PB02. PB, it's a little b. I like this one. Is pure, spongy lead, which is PB. Point three. Point three. Each cell produces about 2.1 volts OCV. What's that mean? Okay. And 2.0 CCV when fully charged. Now, I'll tell you something, funny thing about fully charged and batteries. You cannot take a voltmeter up to a battery and just put the leads on, positive and negative, and take a reading and figure out if that battery's good or bad. You can to a point. If it says 10, it's dead, I guarantee you. But you can come up to a nearly dead battery, like you tried to start your car or something, and it, click, 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 click. Oftentimes you can get out and actually take a voltmeter, put it across a battery, and you can see 12 volts. Or even 11. I go, well, hey, that's enough to start a car. But it's not, because what are you reading? OCV, and that's very different than closed circuit. And so try reading it closed circuit where you're hitting the starter, it's 2 or less. So you can't do that with a battery.
I had to do that with the 24-volt system yesterday.
And so how do you manage it?
Well, you put the test leads on there, and it was like 23 and a half volts, and then as soon as you applied power through the scissor lift, it dropped down to 12, 10.
Right, so the battery's dead, right?
Yeah.
So there's a good point. So the open circuit lies to you. It tells you that the battery's good. But the closed circuit doesn't lie to you. It tells you, yeah, this isn't going to work. Not that you can't get fooled, because if you had something that's a dead short, it'll draw that voltage down real quick. You're like, the battery's dead. No, you're melting the wire somewhere. So, there's different things. All right. So the cells are placed in a box. Let's see, cell plug or cell container. Speaking strictly of lead acid batteries, it's the plates make the difference. All right, it says that right there. Plates make the difference. So you guys can take a look at this battery. I don't know where it came from necessarily, but you can see the plates in there. You can see how it follows across. That was cool.
Wow.
That was tricky.
That's why I wear safety glasses. All right, so they're placed in a container, which obviously is supposed to be an insulator. There used to be I'll just tell you this in case you go out there in the field. They used to call it a wives' tale. That's not appropriate. People used to say, don't ever sit a battery on concrete because it'll discharge.
I've heard that a lot.
You've heard that. And what I have researched and found is it was true at one point, and this was a very long time ago, that the cases they made out of them actually would leak through to the ground some of the power, and so you could actually discharge the battery. But apparently, all of the newer batteries and the newer construction, the newer plastics, they don't have that problem.
So the battery would ground when it hit concrete.
Yeah, kind of. It would discharge through. But I think that goes back to my story about how I got shocked with the car because of the tires, so different rubber compounds. So just so you know that, if you place one on a, don't make a stink about it. Oh, I can't put it on the concrete, but just it's fine. But somebody else might make a stink about it. Go, yeah, I've just, heard that. Just kind of shake your head. And, how do you want me to do it? So a container is made of hard plastic. A NiCad battery, their container is made of metal. But you guys have seen what the cells look like. You actually can pull them out and hold them. So those cells actually just all go into a metal casing and have the straps, which you have on your little NiCad. That's that little metal strap. Actually connects them all together. And so it goes in a metal case.
But it says to test as well.
You do have to test for leakage out of the cells. Each cell has, let me see, a grid that contains active material. And that's the square lead looking things in there. That's the grids.
Have you ever disposed of any of these NiCads?
Yeah, when I worked out at Clarksburg, it's right on the river, so I just walk across the levee. And
Did you break them in a vice first, or?
no, just toss them in the river.
That'll discharge them too.
No, I did not do that. No, I do know it says to do that, but that's in reference to NiCads. Okay, this is a Q&A question, or I think. The space, what's the space below? The space below the cells, let me see. Well, no, I screwed up what I was writing. So each frame has, let's see, the plates sit on a little shelf with space below. So the space below the cells allows material to collect.
Kevin.
Yeah?
So that's just on the lead acids, right?
Yeah.
Okay.
So below all of these cells, you have enough space down there where you can collect debris down there. Remember, this is a car battery we're looking at here. No, economy, original, and supreme.
The space in between the plates.
See, I've got a bunch of stuff here. What can we cut out here in the interest of time? That's important. Top of the cells, of course, they have the little lugs up here, which you can see that allow the voltage to cross to the next one. They're connected in series or parallel? Okay. Say the top of the battery. And some of them are the sides. Top of the battery contains the positive and negative terminals. Some batteries, well, let me see, and possibly vents. And the vents allow hydrogen gas, oxygen and hydrogen, to vent out. I'm going to go off my notes here for a minute. This is something that's critical and important to your everyday life. You have a battery in anything. And I just told you that it vents out what? Hydrogen and oxygen. What is hydrogen famous for?
Hindenburg.
It's
Now we get
The Hindenburg. If you weren't familiar with the Hindenburg was filled with hydrogen. And there's some controversy as to why it actually exploded, but it was a fabric, and the fabric had aluminized paint on it, so
And it was going through a thunderstorm.
could have been thunderstorm, could have been static electricity. Anyway, the hydrogen lit off, and that's what happened. So we actually have a battery that looks very similar to this. I wasn't going to carry it over here, but it exploded.
Isn't that the car from the show this weekend?
This was my brand new Corvette, the one I could afford. So that's what happens. I couldn't find one with an airplane, which is probably a good thing. All right. So we have on a battery positive and negative terminals. And first lesson here is we have hydrogen gas that is being vented off, and it's around the battery. What does hydrogen gas smell like, by the way?
Rotten eggs.
It smells like rotten eggs. So we have hydrogen gas. If you are charging a battery, and you have over here the charging station, it's plugged into the wall, and you bring a clip lead up and you hook it to here, and you have another clip lead and you bring it to there.
You hooked that up wrong.
Did I hook it up wrong? I should have made that one red for you.
No, I meant you did. You're negative first.
All right. We're talking about something else first. Which do you disconnect first? The positive right here, the negative here?
Negative.
Who says positive first? Who says negative first? Who says something other than that?
Same time.
Who has no same time? Okay.
Negative first.
You all exploded yourselves.
You unplugged the charger.
Unplug the charger first. All right, I'm talking about a charger, and the reason why is because as you disconnect any of these wires, you're going to get a small arc. The only way to prevent that is to shut off the charger. That'd be the zero mode. Unplug the charger, turn off the charger, then it's safe. Otherwise, you're going to explode all this hydrogen around here.
That's the same for like if you're jumping the car too.
Same if you're jumping a car. When you're jumping a car, always disconnect from the good battery first, the car that wasn't dead.
'Cause then you can kill the other.
Right, because a battery that is charging is putting out hydrogen. Charging a lot. All right. Now, if you have the battery in an aircraft, so battery in an aircraft. That's a sad battery.
Halloween battery.
I don't know.
You had to cut off the corner. Just to-
Whatever. Okay, so in an aircraft battery, we have a clamp and usually just a short lead that's going to bolt to the airframe. All right, so it's just going to bolt right to the airframe somewhere. Then that provides a ground. And then we have a positive lead. The positive lead's actually going to go up to the bus bar somewhere,
Or the
something
back.
like that. So it's going somewhere. All right, we're just going to go with that. Which one do we disconnect first?
The negative.
Why do we disconnect the negative first?
Because there'll be no more ground, so it's,
Because of electricity.
there'll be no more circuit.
Okay, it's all about the ground. So I'm going to make green be my aircraft. So the box is in the battery's in a box, and we have pieces of the aircraft all over the place, and that's represented in green. And of course, that is grounded to this over here. So if I take a wrench and I'm like, I don't remember which, I think that I will disconnect this side first, and I connect a wrench from this, and it touches to the aircraft. What is going to happen?
Right hand.
This wrench is going to get very, very hot very quick, and you're going to let go, and it's going to weld itself to the aircraft. And there's how many cold cranking amps in some of these batteries?
700,
600, 700, 400, 300. That's about how many instantaneous amps you're going to get. That's the same reason why a lot of people don't wear rings. I don't wear my ring when I work on an aircraft. I take it off. One guy had a rubber ring. It was kind of cool. Yeah. See.
That's not cool anymore.
But anyway, so this would be bad. So this is going to make sparks and weldy, right?
Yeah.
Okay. Now, if I'm over here on the other side, and I've got my wrench, I'm doing it, and I hit right here, what happens?
A whole lot of.
Ground to ground.
A whole lot of nothing because it's already grounded. This is already connected to this over here, so it doesn't matter. You're just adding another connection. Nobody cares. It's completely pointless. It's whatever. In fact, I'll just do it when I work on an airplane. I'll just hit the side. It's okay. What happens if you swing this wrench around and touch this?
It's all melty.
It gets all hot again. So okay. So you take off the negative first. Then once the negative is off
Free game on top.
and you touch right here, does it matter?
No more connection.
Once this is gone, it doesn't matter. There's no circuit. So yeah.
All right, 2 questions. One is, some airframes are like, I've heard they're known to build up a static charge,
Uh-huh.
and it goes to ground. Can you kind of degrade your battery, or the potential between the 2 terminals, at least a little bit by just flying?
I don't know.
I would.
Never thought about it.
So like on the Cirrus, it's carbon fiber on the side.
Yeah.
Like, so you're not really grounding to the airframe, and it's not really like.
Nope.
So
You have to have ground wires everywhere.
So when you're disconnecting, would you just do all the ground wires individually? Because it's all.
You still disconnect the. As a matter of practice, I would disconnect the negative side of the battery first.
Regardless of the application.
Yes. Well, unless it was a positive ground battery. This is an MG. That's a whole other story.
The second question was.
Okay, second question.
In the manual for the lead acid,
Uh-huh.
it says that the gases are also corrosive,
Yeah.
but hydrogen and oxygen aren't corrosive. So,
Right.
I mean, I understand.
But
the
acid
corrosive
is.
part.
But it's.
It says that the gases that it puts out are corrosive.
That's right. The gases are.
How so?
Well,
It says that it's only oxygen and hydrogen.
that's right. You ever walk in a bathroom after somebody else uses it?
Okay.
What do you smell?
Shit.
That stuff gets in the air, doesn't it? Permeates. So you are going to get a little bit of the acid in mixture. You just do. I mean, just as a matter of principle, working on aircraft, you can see it. You're like, well, there's acid came from somewhere. Guess where it came from? So somehow that acid gets out into the air,
Okay.
and then it settles, and then it's very, very corrosive. Extremely corrosive.
Yeah,
So
it's a liquid and it's turning into, and you have stuff turning into a gas, so it's like humidity in the hydrogen and oxygen.
so the fecal matter's getting around here, even though it's what?
Shit. Keep
You-
it sealed.
So
First
acid
frog
doesn't-
legs, then
It doesn't go into a gaseous state. That's the only reason I was kind of asking. I think.
Okay, so sulfuric acid doesn't go in a gaseous state.
Yeah.
It gets out somehow.
It goes into a vaporous state. Minute,
I don't have the answer to your question.
Okay.
I'm going to tell you why does it do it? I don't know. But here's what I do as an aircraft mechanic.
Is this like calculated?
When I work on an aircraft, my own or even a customer's, I make it a point to disconnect the battery, remove the battery from the aircraft, service it on a bench, and while it's out, I take a mixture of baking soda and water, and I scrub the inside of the battery area, around the firewall, anything near the battery area, wash it off, wipe it off, and then coat it with an acid-proof paint.
Just use Diet Coke.
Acid.
There's such things called acid-proof paint. Yeah.
How about to connect it back?
Okay, to connect it back. Thank you for bringing me. So how it happens, I don't know. You got to go to chemistry class for that. All right, so, not a chemist here, mechanic. Okay, so how to connect it back? Just the opposite. First, this one. First, you go on the positive. Why? Because if I do the positive first and I hit, nothing happens. Then I put the negative on because why? Because while I'm doing that, if I hit, nothing happens. So, disconnect the positive first. Somebody once said, and I like this, leave the positive on the longest. So it's the last to come off and the first to go on. So the positive's always hanging out there. It's the longest. Whoa, we missed break.
We didn't miss it, we didn't take it.